Perfect. All right, here we go. So let's make sure everybody is in the correct class. This is Math 13-14, that's college algebra. Section 18, I guess that doesn't matter. I do need to talk to you a little bit about this class because it is quite possible that you have been placed into the wrong course. So is there anyone here who is a STEM major? Engineering, computer science, math? No? Okay, so what kind of majors do we have in here? Biology? Any biology? Okay, have you checked with your institution to make sure that this is acceptable? Okay. What are some other majors we have in here? Nursing? So I know this is okay for nursing. What else?
Criminal justice.
Criminal justice, I think this will work. Kinesiology? Okay, like physical therapy, things like that. So everyone feels like they're in the right place? Okay, the reason I ask is because we have two college algebras. So one of them is for people doing a certain thing, the other one is for students doing something else. So I would hate for you to go sit through an entire 8 weeks, even though it's going to be so much fun, and, at the end realize you had to take the other college algebra. So if you have any questions about that, please look into that now. Don't wait till it's too late, or not too late, but you've wasted time. All right? Okay, I need to grab one of these towels back here. Okay, so next question is, how many of you are first time in college? Like this is your first semester ever? This one? Okay. How many of you are from a transfer institution? You're just here for the summer, taking some classes while you're in town? Okay. Everyone else pretty much is here? Okay, all right. So you've decided to take a math course over the summer. So you have to realize that we are going to take 16 weeks worth of work and compress it into 8 weeks, which gives you less time to absorb, less time to practice, right? So hopefully you have enough time in your life to balance things out. Now this is not a very heavily intensive math course, but a lot of students that are in a course like this usually are not huge fans of math. Like how many of you just love math? Yeah, see, I'm the only one, right? My goal here is to help you achieve your goal to get through the math. So I'm going to present it in a way that you're not going to be building a bridge for us later down the road, right? You're not going to be, people's lives are not going to be depending on your mathematical skills, right? That's what the engineers are there for. So I want to keep everything pretty laid back. We'll use some technology. We'll actually use our phones to do conversions, things like that, milliliters to whatever. So we're going to try and use technology when we can, but unfortunately we still have to cover like mathy stuff, solving equations and parabolas and things like that. We have to do it. So, but I just want you to know that I know in the back of my mind that you have a certain goal and it's not necessarily math related. All right. Now I have to go and just kind of show you the syllabus. So this is what we call our Canvas page. Oh, that doesn't work good. I'm going to go in here and show you what it looks like from your point of view. So does everybody know how to get to Canvas? Is there anyone who has no idea what I'm doing here? Anyone, no clue? So everyone's all right with that? Okay, so this is our main page for the course. Anything that I send to the class will be posted here. So if I want to send you an email, or if you want to send me an email, it needs to be done through here. Don't go to your Yahoo account and send me an email. Go here, go to, where the heck is it? Oh, over on the side, sorry. Inbox here, and that's where you'll communicate with me. Now, I don't want to go through everything here because it'll take too long, but we have this class packet. This is the only materials you need for the class are you can get electronically, or you can go to the bookstore and get them. Has anyone gone to the bookstore and got them? No? Yes? How much were they? $13. Okay, so it's just a bunch of papers in a packet. You can put it in a 3-ring binder. That's what I'm going to be going through. The whole semester I'll be following that packet. And other than that, you need a calculator. Now, there is a required calculator for the course. You're supposed to have this TI-30SX. Okay, that's the one you're supposed to have. And the only reason you're supposed to have this is because I'll tell you which keystrokes to use for certain problems, and if you have a different calculator, then you're not going to know what I'm talking about. Does that make sense? So I don't care if you use a different calculator, but if you need help learning how to use it, you're going to have to talk to me after class, or hopefully if there's enough class time during class, I can help you. But I'm really going to be focused on helping students with this calculator. So I believe this calculator you can get it for like another 10 or 15 bucks. So all in for this class, I'm thinking 30 bucks in materials. All right. So it's in the syllabus. I'll show you. I think you can get these on at Walmart, Target, Amazon. You all heard of Amazon, right? Okay, so I'm not going to look at the packet. We have a schedule. So if you click on this, we'll go ahead and look at this right now. That'll download a PDF file, and here's kind of the day by day what we're going to do. So today's Monday, June 10th. We're going to do introduction, we're going to do fractions, we're going to do order of operations and linear equations. And then out of the packet, these are the homework problems that you should do from the packet. All right, and the whole semester is laid out like that. Look at that. When's our first test? Yeah, in a week. Like next Monday is our first test. And you might ask yourself, why are we having tests so soon? Well, because you're taking an 8-week summer math course, that's why. And we have 4 tests. So we have that test, and further down the road we have our test 2, then we have test 3, then we have test 4, and then one more day, and then our final exam. All right? So during the summer there is no finals week. If you're familiar with college, you have a week of finals. In summer, the last day of class is your final. So that's our last day, Wednesday, July 31st. We'll come in, we'll have the whole class to take a final. All right? So I suggest you print that out and put it in a folder or something. I have it right here, so I can always reference it every day. Any questions up to this point? I haven't even introduced myself, I'm sorry. But I was going to get to the syllabus, so let me just get to that now. So class lectures, those videos, you click here, okay? And that'll take you to YouTube. And right now there's nothing in here. But later on today there will be a video of day 1 from this class, all right? You can watch that. Now I think I'm going to take this old class lectures out. Those are just videos from past semester. So I think I'm going to take those out of there. Files, homework solutions, all of the problems you do for homework, the solutions are already here if you want to look at them, all right? So that helps out. Yeah, let's look at the syllabus. So we are here from 11 to 1:40, right? It's a long class, right? So we'll probably take a break somewhere in the middle. We'll take like a 10-minute break and then come back. I think that's realistic. My name is Mr. Robert D. Giovanni. You can call me Robert, it's fine. Mr. D Giovanni, whatever you want. I don't care. Just, some level of respect, not just like, hey, I actually offer you my cell phone number. So here's my cell phone. And I don't do this because I really like my students. It's that I offer, I teach online courses. And so because I teach online, I have to be there for my students, and so I give them my cell phone number. So I also provide it to you. I may as well. So if you're ever at home and you're working on a problem and you're stuck and you just can't figure something out, feel free to call me or text me. I like text better. You can take a picture of the problem you're working on. You can take a picture of your work and then send it to me, and then I can get your text, and I have a phone that I can write on it, so I can point out where your mistake is, and I can write my own solution. I get that real time. I don't have to go wait and go check my email. So this is a very fast way to get help. So feel free to do that. Just make sure that if you are going to do that the first time that you do it, please put your name and what class you're in so that I know who I'm talking to, all right? So please put in your text message, who you are, what class you're from, and then that way I can just scroll up and see who you are if we're talking. All right, office hours. So it's the summer, so our office hours are not quite the same as they are during a normal semester. I can be here any day, Monday through Thursday. Campus is closed Friday, so I can't be here. But if you want to meet with me before or after class, well, it would have to be before class because after this I have a class, so I don't have time after this class. But we can meet before or on Tuesday or Thursday. I'm free. Just make an appointment. So you'll either text me or call me or email me, and we can meet up. All right. Now we do. If you need help, we have a tutoring lab across the hall, room 308, and I believe. Let's see. I don't see their schedule up there on the board yet, but we'll see what their hours are for the summer. All right. I already told you about the packet that you need. Excuse me. And then the calculator. This is the calculator right there. All right. So I don't want to go through like a full description. Are we running out of chairs? Let's see. We have one here. We have one there. One there. I'm not going to run through like what we're going to do, everything, because we'll get to it as we go. You probably want to know about your grade. So here's the way the grade is broken down. Quizzes and homework mean that I can give you a quiz like it. Just be prepared for a quiz at any point in time. So if whatever we cover today, I can give you a quiz on that today. Like I wouldn't like punish you and make sure you have mastered it. I might give you a group quiz where you work together. Or next class I might give you a quiz. But anything we've done is fair game, and the quiz can come in the form of, pop quiz, group quiz, take-home quiz. Hey, we're just going to give you a quiz grade because you were here today. It just expect them at any time, all right? And if you do your homework, you'll be fine, all right? Do your homework, understand the material, and there won't be any surprises. And then homework, it says it's part of your grade, but really, I'm providing you the solutions already. So that would be more of like me checking, like me come by and say, let me see your homework from last night. Just walking around the classroom and giving everyone a quiz grade based on that. Does that make sense? I'm not going to collect it and grade it. The solutions are out there. There's no sense in me doing that. All right? And then we have our exams. We have 4 exams and then the final, and those are the weights of each of the exams in the final. Now, each exam will cover its own material. So exam 1 will cover everything up to exam 1. Everything on exam 2 will be stuff between these two. Exam 3 will just be stuff after exam 2 until we get to the final. When we get to the final, that will be a more comprehensive exam. And I do intend on giving you all reviews for each test. All right, so the review will be very similar to what you see on the test. All right, so if you can do the review, you're in business. We good? Okay. Attendance policy. So in this class, because it's a summer class, you can only miss 2 days, like 2 unexcused absences, and then you've exceeded the number allowed. And then at that point, what happens? Let's say you miss 3 days, what happens then? Y'all know?
You're suggested to drop the course.
Pardon?
You're suggested to drop the course.
You were suggested, okay, yes, I might suggest you drop it. I don't know, it depends on you. If you understand the material and you just aren't coming, then maybe I wouldn't suggest it. So actually, as soon as you miss 2 days on that 3rd absence, it's actually up to me then. It's no longer up to you. So if I want to drop you, I can. If I choose not to drop you, I can choose not to drop you. I can choose to just fail you, not drop you, not let you finish the class, and just give you an F in the class. All right, so, and I'm not telling you this because I'm that way. It's just, in college you have to understand that as soon as you exceed your allowed absences, your grade is no longer in your control. It's now passed on to the professor, and it's up to them to determine how they want to handle it. All right? Okay, so I put here, if you stop attending, contact me. It's your responsibility to withdraw. So if you decide after today or maybe a week down the road you don't want to do this anymore, don't just stop showing up and assume I will drop you. You must withdraw from the class. All right? I don't have my statement in here about technology. Oh, there it is, behavior policy. Here we go. So this is what, 2019? Yeah, 2019. It is 2019. So we all have phones. We're all connected, right? It's difficult to come sit in a classroom from 11 o'clock to 1:40 and not be doing something on the phone, right? I mean, it's difficult. I understand that. But I'm going to ask that you, for this time that you've said you are going to be here trying to do this math, that you stay off your phones, all right? So no texting or using your phone or sleeping during class, all right? If you're tired, either don't come to class and take your absence, or just go out in the hallway, lay down on one of those benches, or just go walk up and down the stairs 5 times and get your heart rate up or something, but don't sleep in class, right? Because it'll cost you 10 points on your next exam, all right? And then I'm gonna ask you to leave, and I'm gonna count you absent. So it's not worth it. And I know that's pretty harsh, but I want you to be here paying attention, and don't be trying to do stuff under your table with your phone. If you really have something that important on your phone, just walk out of class. Just leave the class, all right? Come back in, that's fine with me. Just don't do that 10 times. Uh-oh, okay, we got a visitor already. What's up? Are you gonna tell us about the lab hours?
Yes.
Awesome, that's,
If I'm not interested.
go ahead.
Good morning, how's everybody doing? All right, you guys.
It's an energetic bunch here.
Okay. My name is Al, and I'm one of the tutors here at Northwest Vista, and I come to talk to you about 2 places that if you're having problems with your math, you need help, there's 2 places here that you can get help. And guess what's the best thing about these places? Anyone? It's free. Who doesn't like free stuff? Okay? So, 2 places that if you need help with math, you can go there, it's free, and we're going to try and do our best to help you out. Okay? Now, I'm not going to lose the time telling you the schedule. I have it right here, and I'm just going to go ahead and pin it to the board here. I'm sorry. Now, one thing to keep in mind, this schedule right here that you have, this is the summer schedule. You're going to notice that Friday and Saturday is not there because Northwest Vista during the summertime does not operate Friday and Saturday, okay? So, just come to us and visit us. I'm going to tell you the difference between the both math labs. First of all, there's the math lab that is in room 316. Basically, if you walk out this door, make a right, you walk down the hall, you're going to see it immediately. Before you hit the bottom, you're going to see it to your left, okay? Now, what are the difference between the both places? Okay, I'll start with the math lab, which is room 316. And there, we take care of students from 0410 all the way to calculus. Basically, the way it works is that you go into your room, you find a computer, sign in, okay? It's important that you sign in. I'm not sure if you require hours.
Not here.
No, do not require hours, okay, but still go ahead and log in, okay? Have a seat, you start doing your work, you get stuck in a problem, raise your hand, and 1 or 2 is going to come to your table and help you out. Now, the tutor is going to be with you about 3 to 5 minutes. It's not that the tutor is trying to drop you like a hot potato, it's just you're going to see the tutor jumping to your table helping other students, okay? Now, say those 3 to 5 minutes, they're not doing it for you because you need in-depth help, right? Well, here's where room 308 comes into play. It's called the Math Ability Center, MAT for short, okay? There we take care of students from 0410 up to 1414. Basically, it works the same way. Just go in there, sign in, and 1 or 2 is going to meet you and greet you. And we're going to have a tutoring session, but this time it's going to be a 30-minute session, one-on-one. Not 5 minutes, but 30 minutes, one-on-one, okay? Now, one thing is that you can go to room 316 as much as you want. You can go, okay, there's no limits there. 308, that's going to be limited to 5 bits per semester, okay? So make sure you use those wisely, okay? Other things that we do in room 308, if you happen to miss a class, you can come by and we'll try to help you out for that class that you missed, okay? Now, please understand something. How long is this class? Minutes. How long? This class. How long is this class?
I don't think we've done the math on that yet.
Okay. I think it's over 100-something minutes, okay? Now, if you come to visit us because you missed a class, we're not gonna give you over 100 minutes of tutoring for that class that you missed. It's gonna be just 30 minutes, so please make sure you come to class, okay? We're gonna try and help you with some of it, but try to come to class, that's important, okay? I leave you with 2 notes. Please attend class, that's important. And again, every semester, it does happen. I've been doing this since 2013. And every semester doesn't fail. A student comes up to me because he or she has missed 2 or 3 classes, and they're like, and in my head, while they're telling me the story, I'm just thinking, well, how am I gonna fit over 100 minutes of classwork into a 30-minute session? So you see what, you need to come to class. You can't take it for granted that if you miss the class, you're gonna go to the lab and you're just gonna make it what you want in class. It doesn't work that way, okay? So please come to class, attend class. The other important note that I'll let you with is to also take notes. Even if you don't understand what you're doing, please take notes. Now, this is what, 13, 14, right?
Mm-hmm.
Now, would you agree with me at this level right now, you should be aware that a math problem can be done in different ways. Yes, no, maybe. Yes, it can, right? So this is what happened. Even if you don't understand what's happening in the class, but you're taking notes, you come to us and you say, I don't understand today, Mr. Giovanni, when he explained this to me, but here I copied this down. So I'm able to see that Mr. Giovanni used certain way of doing this particular problem. So we're going to try and follow what Mr. Giovanni is doing in the classroom. That way we don't mess up things for you guys, okay? It's not that we don't know how to do it, we know how to do it, but in different ways, and we don't want to mess your ways up, okay? So, questions for me? None? Oh, one more thing, we do lend out calculators, but let you know that it's a first come, first served type thing, okay? So, we can help you out momentarily, but as the semester goes, calculators, they lend out very quick. So make arrangements for if you need a calculator. Okay?
You mean lend out for short term or long term?
Just for a short term.
Like a day?
3 hours.
Yeah, okay.
For tests, something like that. Not that you run out with the calculator and turn in a week or anything like that.
Yeah.
Okay?
Okay.
And you're going to need, for the calculators, you're going to need a student ACES ID card. You can get one of those, I call it the gym building. You just walk over there. It takes you about 5 minutes to get one of those ID, and it's free. Okay? Questions from me? No? Sure? Sir,
Thanks,
thank
Al.
you very much. Have a great semester. Please come visit us.
Thanks, Al. Take care. So I think that illustrates again why I record my classes. It's because of that. If you miss class, you're not over there trying to explain to them what happened. You can at least go back and see how I work through things and what I expect. So, all right, back to the behavior. So on this thing with the phone, I have to say that I'm leaving. Today is the first official day I left my 10-year-old daughter at home for the first time ever. I've left her for like short periods of time, but so she's at home by herself until 5:30 today. So I'm like, I've got my phone in my pocket. I'm waiting, like if she calls. So just like if something you're expecting something, you know, just take it outside. If my phone starts going off and you know, I'll say, excuse me, I'll walk out. Okay. Same thing with you. All right. Just keep it silent. Can we do that at least? Right. So I'll silence my phone. Okay. Any questions on the behavior policy? You sure? No volunteers to test the policy yet? All right, let's keep going. What's going on? There we go. So the rest is the schedule, and then there's a bunch of administrative things, institutional policies, and blah, blah, blah. Now, there is something here that we should discuss. Don't worry, we're almost done. SOBI. So SOBI stands for something. I don't even know. There it is. Strategies of Behavioral Intervention. So this is relatively new. I'd say within the last 8 years, this statement has started appearing in every syllabus. So any ideas of what this has to do with? It has to do with just the crazy society we live in these days, right? You find people, this is saying, hey, look, if you see someone that just doesn't, things don't look right, you know, like their behavior is something that you just is setting the red flag, you know, you need to do something about it. Be proactive, all right? So we need to pay attention to things that are happening around us, unfortunately, right? And so, you know, there's a quote. I actually told my daughter this today when I was leaving the house. We made a plan. You know, what happens if there's a fire? What happens if, you know, someone starts trying to break into the house, right? We start to have a plan, not to scare her, not to freak her out, but to have a plan, right? So this saying goes that luck is preparation meets opportunity. So we want to, when we're here in this class, we want to be prepared for anything, right? So one thing I like to think about is, you know, what if there's an active shooter, right? This is your generation, okay? This is where we are, okay? So what would happen, right? We hear gunshots in the hallway. What are we doing? Yes, sir.
Probably shut all the lights off, put the tables, barricade the door, and then get to the nearest location away from the window. That way they can't see who's in the door.
Okay, so everyone over there is going to barricade the door, and everyone over here, we're going to hide and huddle up in the corner.
You're going to use the tables.
Yeah, y'all are going to use the tables to barricade while we huddle into the corner, all right? Yeah. Does that sound like a plan? So should we keep the door locked or should we keep it unlocked? You don't want to lock it? So if you leave to the restroom, that means whoever's there in the corner has to let people in and out. You all right with that over there? Fine? Okay. So we all agree to keep it locked? All right, we'll keep it locked. So there's a little magnetic strip that covers the door right now so that you can just come in, but I did lock the door. Now we also have to keep in mind that there are exits here. I mean, there are ways to go, right? We have a glass window right here in our door. It's not very secure, right? So how about there? How about those windows? Is it a 20-foot drop? Have you checked?
We're on the second floor.
We're on the third floor.
Well, then it's at least
You sure?
It's over 20 feet.
30 feet. Yeah.
Sir, open the blinds. There you go. Look out that window. What do you see down there? A roof. Okay, it's not a 30-foot drop. Okay, so that is an exit, and that's where we go. All right, now this one, I do not believe, does this one go to the roof?
Yeah.
Okay, now there is a drop, but it's not 30 feet. It's more like, what would you say, 8, 10? You're surviving that drop for sure. Okay, and then you're running. Then you're running on this awning, and then after that, I don't know, but would you say that's survivable out that way? Broken leg maybe? Might blow your knee out. Okay, so I don't plan on ever being huddled up in the fetal position under a desk waiting for somebody. I will be going that way, okay? And so this is what I'm saying, preparation meets opportunity. We know now that's an exit, right? Okay. That's kind of crappy we have to talk about that, right? Now, I've actually been teaching for a long time, and I've been every single class, every first day, I've been doing that back from early 2000s. And back when I used to do it back in early 2000s, people were just like, what the hell's wrong with him? You know, like, well, why is he talking about this? And now, 2019, everyone's like, yeah, cool, check, we got it. You know, no big deal. All right, so pay attention to what's going on around you, all right? Also, keep in mind that all colleges in Texas are now, all public institutions are now concealed carry. So if you have a concealed handgun license, you are allowed to carry on campus. Just so I'm pointing that out because there could very well be somebody who's armed in this class right now, all right? Not to scare you, but I mean, if someone's out there shooting and you've got someone in here with a gun, I think you might be happy. You might not, I don't know. Maybe you don't want any guns around you, I don't know. But I'm just saying, keep that in mind, you know? Okay. All right, enough with the politics. Are we done? Can we move on? I keep doing this because they just put these glossy things up here last semester, and it doesn't work with my mouse, but I've been doing that forever, so I'm gonna have to get a new habit here. All right, we're done with the syllabus, discussion board, grades. Here's where your grades will be. Okay, I'll post your grades there. Anything else before I close this out? I'll let you explore that the rest of the way. We're good? All right, I'm going to take attendance. So, I mean, this is college. Like, to me, I shouldn't have to take attendance, but the state of Texas requires it. All right? You know how Mr. Al was talking about these 2 labs? They're free? They're not free, right? You pay taxes? Who pays taxes in here? We all pay taxes, right? Okay, this is your tax money right here, right? This is your tax money. You get 30-minute visit, you get 5 of them. Why 5? Because that's how much we can afford to give students. So this attendance is to verify that you are not wasting taxpayers' money. Right? I know you pay tuition, but that tuition is subsidized. I mean, in other words, part of it, community college is inexpensive because the taxpayers in Bexar County are footing part of the bill for you. So this is to hold the student accountable for being here, all right? So find your name and the date and just initial. That's all I need, all right? If your name is not on that list, please let me know, and then well, if your name's not on the list, there's a space at the bottom you can add your name, all right? All right, well, I guess we're ready to do this, unless y'all have any last words or questions. I didn't bring them today, but next class I'm gonna give everybody a little like popsicle stick, and you're gonna put your name on it. I'm gonna collect them, and then I'm gonna keep them up here, and during class I'm just gonna pull names, and as I'm asking questions, I'm just gonna pull names, and then you're gonna have to respond. All right, so I'm gonna embarrass you, I'm gonna put you on the spot, I'm gonna do all that, and that'll help get you a little more engaged, I hope. All right, so we'll do those popsicle sticks next time. Part of what is important here for us is that you participate, all right? This class will be a long-ass class if we just sit here and like that. If you are engaged, then things will go a lot faster, I think, all right? So let's get going here. I want to bring up the packet. Where did I put that packet? There it is. So here it is, and we are going to cover today, starting out with the basics. This is review, all right? It's the first part of today is going to be review. So if this stuff seems pretty straightforward, good. But there are some little things in here we need to make sure everybody is on the same page on, and there are different ways to do these things. So let's kind of work through this. God, this is really going to be irritating. We are going to start by multiplying and dividing fractions. Is it fair for me to say that that's basic stuff or no? I don't want to insult anybody. Let's see if it feels how it feels to you. Now, when it comes to fractions, when you're learning about operations with fractions, we actually do multiplication division before we do addition and subtraction. Does anyone know why we do multiplication division of fractions before addition and subtraction? What's that? Order of operations? Okay, I think I know what you're talking about. I'm talking about when we're first introducing it to you. You're correct. In order of operations, we always do multiplication division first, but it's like when you're in grade school and you're learning numbers, right? They give you numbers and they teach you how to add and subtract first, right? And then they teach you multiplication division. But when we get to fractions, we actually do multiplication division first. Why?
If you divide it first, you won't have the same answer as multiplication first.
Let me see. Let me write this down. We won't get the same answer, but What I'm saying is, why are we doing this problem up here before we're doing this? Why are we doing this before we're doing this?
Because they don't have the same common denominator.
It's actually harder to add fractions than it is to multiply. When we multiply fractions, it's more straightforward. We just multiply straight across, right? But when we add fractions, we have to get this thing like a common denominator. It's more complicated. So we actually do this before that, all right? So that's a little like perspective on why we're starting with this. All right, so let's do that problem right there. So I'm going to ask for some volunteers because I want to see what sort of different methods we have for this, because there's probably two or three different ways we could do this. So anyone? Any volunteers? Anybody from this table maybe?
I'm not good enough with that.
Okay. Well, I think it's more of a confidence thing. You know, like once you see it done, I think you'll be like, okay. All right. Math is a lot of math is confidence, just believing that you can do it and recognizing what you need to do. You got an idea? If you're wrong, I'm going to ask you to leave and count you absent, right? Look, you want to fail, you want to make mistakes right here, right now, not on the test, okay? So it's okay to be wrong now. In fact, I want you to be wrong now. Yes, go ahead. Okay, so cross simplify. Okay, so what you're saying is when we multiply, if we see anything like that goes into two numbers, we can cancel them out or simplify or reduce. So I think you're saying like 4 and 16 are multiples of one another. So 4 goes into 4 one time, and 4 goes into 16 4 times, right? We've seen that? That look familiar? And then can I do anything with anything else? 3 and 9. So 3 goes into 3 once, and 3 goes into 9 3 times. Right? So at the end of the day, this really looks like this is equal to 1 over 3 times 1 over 4. So that's me reducing, right? Canceling, but we'll use the word canceling if we have to, but technically it's called reducing, all right? So is everyone clear with that? Now what? Get a common? So do we need that with multiplication? Do we need a common? Not with multiplication. With multiplication, you just go multiply straight across. So we do 1 times 1 and 3 times 4, and that'll be our result. So 1 times 1 gives us 1, and then 3 times 4 gives us 12, and we get 112. All right? Any questions on that? All right, let's do it a different way. What if I don't do that reducing and I just go straight across now? What would I get? So 12 over, and then this is going to be a bigger number, isn't it? What's that going to be? 144? So maybe you need your calculator for that, whatever. Okay? So these aren't the same answers, not yet. Okay? Because this one is not reduced. You still at this point have to ask yourself, is there a number that goes into both of these? And in this case, 12 goes into both. So 12 goes into 12 one time, and 12 goes into 144 12 times. So you get 112. So you get the same answer, right? It's just a slightly different approach. Which way do you like? The top one or the bottom?
The top one.
Top one? Top one worked out nice because you didn't have big numbers to work with, right? This one, you didn't have to do any of this reducing, but at the end, you kind of still had to, right? So they're both correct, right? I don't care which way you use as long as you do the right thing, all right? All right, let's take a look at division. So when you take two fractions, like 7/8 divided by 2/9, what's the big difference here? Can you all see this okay? Is it too glary or is it all right? All right. So what's the difference with division? Yes?
They gotta flip.
You got to flip. You got to flip something. Which one gets flipped? the 2 over 9. So when you do division, what you're going to do is you're going to flip the second fraction over and turn it into multiplication. And that's just the standard procedure of what we're doing, of how we do it. So this becomes 9 over 2. All right, so what we do is we transform, so listen to what I'm saying here, we transform division into multiplication, but we have to take 7/8 and multiply it by the flip of that, which is actually called the reciprocal. So division is the same as multiplication of the reciprocal. Now what? We're back to a problem like this now, right? So we see, you know, can we reduce anything? I don't think we can get any numbers that go into both. So we're just stuck here. We just go straight across, all right? So what do we have on top there? 63. And on the bottom? 16. Now, question. Do I need to look to see if this reduces?
Yes.
I should check, but I can tell you right now it won't. Why can I tell you it won't reduce? How can I tell you that?
The 16 has a lower, what do you call it? The
One
lower
is
number.
even and
Because this is smaller than that?
Yeah.
No, because you could still look at, if I had 12 over 4, that fraction would reduce, right? So what I'm saying is when I get to this, I know I don't have to reduce. Why do I know that?
16 is from number.
Yeah, these didn't reduce, right? If these don't reduce, right, then I shouldn't have.
Is the prime number?
Nope. Nope. It's what I'm saying is because there was no cancellation here, I know that there's not going to be any cancellation here. All right, but if you want, just check it anyway. Nothing goes into both of these. And if you have prime numbers, you can still have a fraction reduce. I'll give you an example. 5 over 25. No, that's not. Yeah, I mean, I don't know if this is what you're saying. 5 is prime, right?
Yeah.
But this still reduces to 1/5. So, okay, so division is multiplication of the reciprocal. Let's see what else we got here. Why don't you try on your own real quick to do, that didn't work. Why don't you try and do number 4, and I'll make it a little bigger so you can see it. Why don't you try number 4? I'll give you like 2 minutes, tops, a minute and a half to do number 4. All right, that good? I forgot to point something out on the previous problem, and I should have said it. You know how the first thing we did was we flipped it over, we multiplied by the reciprocal? You always have to flip it before you try and reduce anything. On the previous problem, when it was written, if you tried to reduce first, it would have been incorrect. All right, so we always have to first do the multiplication of the reciprocal, then you're allowed to do the reducing. So what do I turn this into first?
18 over 14.
So 4 over 9 times 18 over 42. And now, did you reduce? Okay, so you should have, let's see, 9 goes in 9 once, 9 goes to 18 twice, and then what about here? Does it go in? 2 goes into both, right? 2 goes into this twice, and 2 goes into here 21 times. So we're going to be doing 2 over 1 times 2 over 21, and then you just go straight across, so 4 over 21. There we go. You'll get that? Okay. Let's look at the next one. All we're doing right now is we're kind of breaking out the toolbox, making sure we remember how to use a hammer and a screwdriver and all that, and later on we'll build stuff, okay? But right now we just have to make sure we got the mechanics of the basic operations down. Look at number 6. We have something new here. So before I do that problem, I want to talk about what that is. So how would you say that? Like, speak. Like, how would you say that? 1 and 4 ninths. 1 and 4 ninths. This right here is called a mixed number. And you will see mixed numbers appearing throughout the class. But realistically, like in mathematics, like if you're taking Math 14 right now, which is the other college algebra for like engineers and stuff, we basically like do away with these. We stop using mixed numbers. So what we do instead is we convert this into what's called an improper or proper fraction. So do y'all know how to make this turn into like just a number over a number?
Multiply the 9 with the 1 and add 4.
Yeah, you're going to do like 1 times 9 and then add 4, which is 13. And then you just keep the 9. Does that look familiar to you all or no?
Yes.
You're okay with that? Okay, so this right here is called either a proper fraction or an improper fraction. Or I'm not even going to use that. I'm just going to call this what it truly is, which is called a rational number. I should spell number right. It's called a rational number, coming from the idea of a ratio. It is a ratio, a fraction, okay? So it is a ratio of 2 numbers. So when you're dealing with mixed numbers, you can always turn a mixed number into a rational number by doing this times this plus that and then over the denominator. Or what if I started with this and wanted to get to here? How do you get from here back to here? I would have to go and do like old school division. I would have to get my little division box out. Right? I'd have to do that. 13 divided by 9. Say 9 goes in 13 once. 1 times 9 is 9. Then subtract, you'd be left with 4, right? 9 doesn't go into 4, so that would be your remainder. So back in early grade school, you do like R4, right? But then later on, you learn that that's like 1, and then you do 4 over 9. So to go from here to here, we should be comfortable, and then going back, we should be comfortable. Is that all right? And then there's also another way to write this number, and that's to just get your calculator out and do 13 divided by 9 and get like 1.444, and it just keeps going. So we put a bar there, which means it repeats forever, right? Y'all seen that bar before? Okay. So this is mixed number, this is rational number, this is what we call a decimal. And in this class, sometimes I'm going to want the answer as a rational number, and sometimes I'm going to want the answer as a decimal. All right? So it depends on what we're doing. All right, now, we've done all that. Now, how in the world are we going to do this division? How do you think we're going to do this division now? Now that I've shown you that. 1 and 4 ninths divided by 2 and 1/4 or 2 and 1/4. How do you think I should go about that, or how can I go about that? Go ahead. Yeah, why don't we turn them into the rational numbers first? Okay, so if I transform this into a rational number, we just did that, it was 13 over 9. and then divided by, and this one, what would that one be turned in? Someone want to tell me what that would be? What was that? 9 over 4? We all comfortable with that? 2 times 4, 8, add 1, 9 over 4. Okay. Oh, wait, can I cancel these 9s? Okay, so this is what I didn't point out earlier. I need to make sure I point out. We cannot cancel these 9s because we have division. We have to flip first and then cancel the 9s if it's possible. In this case, when we flip them, they won't cancel anymore or reduce. So be careful with that. 13 over 9 times 4 over 9. And now you see you can't do it anymore? Okay. Now, does anything else reduce? Like, nothing, right? I don't see anything that goes in there, so I think we just have to go straight across now. What's that top one there? What is it? 52 over 81. And again, this is where I was saying, I'm confident that this is not going to reduce now because these didn't reduce. So I don't really need to invest any time or energy trying to figure out if there's something that goes into both of those because it would have happened here. So I'm done. It's fully reduced. Just for practice, and I know a lot of you don't have your calculators right now, but if you have a calculator, just make sure you can turn that into a decimal here. I'm getting 6.4197. My calculator keeps on going. So we have to stop at some point, don't we? So what we do is we put this squiggly equals like that, and that means approximately. All right? So what we're saying, it's approximately this number. And you can stop, at the 4, at the 1. You might round that up to a 2, but I'm not real particular about that in here because, again, we're not in this class to go land a man on the moon again, right? We're in this class just to get through the credit and move on with our biology or criminal justice or whatever it is, all right? Okay, we good? All right. So I like to throw in some random useless, I'm not going to say it's useless information, but I like to just throw in some things, kind of keep your brain going a little bit because this can get a little bit dry. I have a question for you. It is math related. Imagine that I had a perfect container that held exactly 1 cup, all right? So this is a theoretical problem. I have this container that is exactly 1 cup. And what I want to do is I'm going to take this pitcher of water that I have, and this is empty right now, and I'm going to pour into it 1/10 of a cup, okay? So I poured in 1/10 of a cup of water into that. So now my water's down here somewhere, right? There's my water. Make sense? Now what I'd like to do is pour 1/100th of a cup in. So that comes up, you get a little more water in there now, right? So the water level came up a little bit. And then after that, I want to pour in 1/1000th of a cup. Okay? And then after that, I'm going to pour in 1/10,000th of a cup. All right? You get the pattern? And I'm going to do this forever. I'm never going to stop. The question I have for you is, does this cup overfill? So take 15 seconds to think about it, and then we're going to vote. Are there any questions about it? About what I'm doing? Do you have a question? Yes.
You never stop.
I never stop. So I do this forever. This is a theoretical problem, okay? So I don't want you to think about evaporation and this is theoretical, all right? Yes?
Your cup is never going to get filled because the water is going to get smaller and smaller and smaller and smaller.
Mm-hmm.
So to the point where it's not even a problem.
Okay, but theoretically, let's imagine that we could get water as small as we want. We'd never get to the atoms This is purely theoretical, okay? So does that change your mind at all, or you're still saying it will never overfill?
Well, maybe in that case.
Maybe in that case.
Pouring, so it is gonna fill somehow.
Okay. So let's take our vote. Let's take our vote, okay? Is everyone ready to vote? Okay? So let's do this. I want you, unless you feel too uncomfortable about this, I just want you to close your eyes and you're going to vote. That way you're not looking at anyone else, okay? So everyone ready? Close your eyes. How many of you think it will overfill? Okay, open your eyes. Hands up. Come on, let's go. Let's see. Okay, all right, now, hands down. Everyone else, raise your hand that didn't raise your hand just now. We're about 50-50 almost, I'd say. About half of you think it's going to overfill, about half of you think it's not. So does anybody want to make a strong argument for the people? What do you think it's going to do?
I feel like it's gonna fill because
You do think it's going to overfill. So let's hear your
the
argument.
cup has a limited space.
It's a limited
If you
space.
go infinite with water, then it'll eventually overflow.
So these are an infinite number of so I guess what you're saying is that this is something, right?
Yeah.
So this is a positive number, right?
Yeah.
And this is a positive number.
Yeah.
And this is a positive number.
Yeah.
And this is a positive number. And so if I keep on putting positive into something that's finite,
It's neutral. Yeah.
right, that's fixed, that eventually it's going to overfill. I like the argument. Okay, who thinks it's not going to overfill? Well, half of you didn't. Does anyone want to argue your case? What's your name?
Tim.
Tim's got a pretty good argument. Did he change your mind, or
I feel like it goes both ways.
you feel like it go the other way? You have a strong argument the other way. Do you want to argue for the other side too?
Well, I feel like since it's getting smaller,
Yeah,
that like eventually it really doesn't matter.
it doesn't matter.
But it does matter.
This argument's pretty good though, right?
It's confusing.
Did anyone else other than Tim have an argument against it overfilling? You had yours, yes? Go ahead.
Because if we draw a line and then put a zero in between, we go to the right, we're gonna go positive, right? And then to the left, we're gonna go negative. So as it gets smaller and smaller, that means we are approaching the zero. And then probably we pass the zero, which means negative. So
Oh, so you're thinking that these are going to get,
smaller.
you're thinking that these are going to get so small that they become negative?
Maybe.
Well, I'll argue against that, because do you agree I'm always going to have a 1 on top?
Yes.
And that's going to be a positive number. And the denominator is just going to become bigger and bigger and bigger, but it's always a positive number, right? And when you take a positive number and divide it by a positive number, you're always positive, right? Just like when you multiply two numbers same sign, you get positive. Same thing with division. Does that make sense? So we can be assured that no matter how far we go out here, we're never going to be negative. I never heard that argument. That's pretty interesting. The way you're visualizing it, getting closer to zero and then thinking maybe it's just going to go the other side.
We go smaller.
Interesting. Anyone else have an argument? So the reason I'm doing this is because, like, we can do this, right? This is math, right? But this is more critical thinking. This is what's important for you moving on. It's critical thinking. We have a situation here that you could argue both ways. I think you have pretty solid arguments both ways. And in this class, we have about half of you think it's to do one thing and half the other. So y'all ready for the answer? Yes? No?
Yes.
So mathematics will settle this for us. And this is one of those things where I'm trying to show you why we should appreciate the mathematics, because we can have a situation that we can argue about all day and never come up with a solution, but mathematics will do it for us, all right? So you were mentioning that these things were getting closer to zero. So someone on their calculator, put in 1 divided by 10 on their calculator, tell me what it is. So you get 0.1, okay? This is 0.1, all right? I'm going to add to that this number. So if you do 1 divided by 100, you get 0.01. And then I'm going to add to that this one, which is 0.001. And then I'm going to do the next one, which is 0.0001. Understand? And I'm going to keep doing this forever. Now, let's put these two together. What would those two together be? So add those up on your calculator. What would you get? 0.11. And then you're going to add this one to it, right? So I'm going to add this one, and then this one. Oh. So if I add these two together, what do I get? 0.111, right? And then when the next one comes,